Dr. Ajit S. Gokhale, founder and leader of National Solutions, Jalanayak of Water Literacy Center at Yashada, Pune, trainers of trainers, independent citizen scientist who has satiated thrust of 250 step slope, hard rock geology villages in several states, has also set up several million liters per day of natural sewage treatment needing least operational and maintenance, has helped farmers in making their land absorb rainwater. His MSc, PhD and special course on water and wastewater treatment conducted by Cranford University School of Water Sciences.
We'll be speaking about nature-based systems for hospital wastewater treatment. Without going into details of what Natural Solutions does and where all we have worked, I'll quickly embark on what we have done here. These hospitals are modern institutions which are established for giving institutional medical treatment. Mostly, the treatment given is allopathic or modern medicine. Going by numbers, most hospitals are private and small. A few hospitals are government funded and big, trust funded and big. Very few hospitals are private and some of these hospitals have medical colleges attached to them. Many big government hospitals have medical colleges. When this presentation was prepared, India had total of 43,486 private beds, 1.18 million total beds, and so on. These numbers are there on internet. In the early 20th century, there was not much awareness about special needs for treating hospital solid waste. And hospital wastewater was not considered different wastewater. Around 1998 onwards, after Dr. Armitra Patel filed petitions, people thought of doing something about biomedical. And after that, they actually started doing something in a few metro cities about medical. And when they say biomedical waste, they only have human tissues, human blood, and material used for operation. Hardly anywhere any attention was paid to wastewater coming out of hospital. These are the links, the sites where you can see biomedical waste. It refers to non-sewage. There are some research papers. Interested people can go into details. This is our Central Pollution Control Board data. The leftmost panel shows sewage treatment plants in Delhi. They found total 30 of them. They found 20 are running under capacity. 5 are running over capacity. 3 are non-functional. 2 are running full capacity. And yet, the wastewater coming out of Delhi is not good. So whatever Pollution Control Board says running under capacity, 20 are running under capacity. Their wastewater certainly should be so good that Yamuna would not be so bad. But despite of having 20 under capacity to full capacity, which means 22 should give best quality water out of 30. 5 should give some good quality water. Only 3 are non-functional. So the quality of water from Yamuna should be much better than what we are experiencing. So there is difference between what people considered to be good and what people perceive really at sight. The lower panel shows water use in hospitals. Average water consumption is 750 liters per person per day per bed. People design things at 135 liters per person per day per bed, or at the most generously designed at 250 liters per person per day. Reality is here. Principal areas of usage are sanitary amenities, HVAC, medical purpose, cafeteria, dining, and so on. The hospitals and healthcare centers, are they sources of pollution? They are significant consumers of water. They generate considerable amount of wastewater, which consists of pathogens and harmful bacteria and viruses, pharmaceuticals and metabolites. They also have radioactive elements, toxic chemicals, and heavy metals. Their impact on the environment: pathogens can spread disease. They can adversely affect the biodiversity. Microbial resistant strains and antibiotics can spread resistance vertically and horizontally. Persistent non-biodegradable hydrophilic chemicals, they pass wastewater treatment and pollute water. Then there are microbial contaminants. 3 into 10 power 5 per 100 ml. There are markers of viral pollution: adenoviruses, enteroviruses, HIVs, prions, and so on. So certainly, hospital wastewater is wastewater which needs treatment, which needs serious thought. And unfortunately, as you have seen, most of the national and international community was quiet about the need to treat hospitals. This is about Delhi. Top Delhi hospitals are spewing sewage into drains, and green pans, including All India Institute of Medical Sciences, big hospital, medical college. These are the wastewater flows. Now, we'll come to our site, where we would like to share a case study with. This site was practically barren on 16th May 2006. You can see only one tiny building over here, and rest of it is hill and fields. In this place, I would like to draw your attention to this place here, valley here, which is dry. May 2006, the valley is absolutely dry. This upper valley also is absolutely dry. There is no water. Let us go ahead. April 2011. Developments are happening here. A medical college is being set up. April 2011, this valley is dry. This valley also is dry. 25th April 2011, valleys are dry. 3rd April 2015, now you can see the hospital which is growing. Still, the valleys are largely dry. It is this hospital which had some business of teaching the medical students. Initially, when the hospital was developed, people around the rural area people, they felt, wow, now we have got a hospital. Excellent. They ignored the wastewater that was coming out of. They were so overwhelmed by the thing that they had hospital. Then later on, the population of hostels increased. The population within the hospital increased. Wastewater started going out of the buildings and nearby areas. Slowly, as the water started entering neighbors' fields, people started complaining. Because the hospital belonged to a big industrial setup, a political setup, people murmured. And they were feeling still grateful that they have a hospital. So they were not much agitating about it. To quiet those sounds, they set up a small facility. Now, while they set up that facility, the whole idea was to set up something, not adequate, something. That something was set up and it did not function. Operators were not proper. There was need to reduce the power consumption so that more power could be given to the hospital. So they timed the aeration initially. Then later on they stopped the aeration. The system was activated sludge based and it could never function properly. Undersized, underoperated, badly managed. At that point, we were called in to improve the functioning of that system. We went there, we studied it, and we said no. This cannot be improved and made function because of several reasons. And we also showed to them millions of mosquitoes which were breeding in their aeration. Earlier, the area around did not have malaria. With hospital coming in and growing, malaria came. In 2013, 16, 16. The hospital's business kept on growing thanks to need for medical college, thanks to the bacteria and viruses and mosquitoes which they were breeding. And after 3 years again they called. And they said, guide us on developing something that is appropriate and good. We said, all right. In between, what had happened was we kept good track of what is happening at site and where that wastewater was getting disposed. It was our own interest to see how ecology works with the wastewater flows. We got a chance to study this place and the wastewater. We kept track of it. We found that nature starts functioning from the moment any impurity enters the water. Here also, it started functioning. The function became conspicuous when large pipes started spilling out large wastewater out into the open. Greenery developed a few meters away and it kept on developing. It engulfed a couple of tiny fields in the valley. And then, as the flow increased, the green area increased. When the the medical college had vacations, the flows were less. The areas dried also. When there was more flow, it flourished. The place was quickly taken over by cattails, typha. Their growth became so thick that it was impenetrable, difficult to move through them. This remained for 3 years. Many birds made their nests. Many snakes were living happily in those fields. development of this wetland by Mother Nature can be seen in these images. 2016 January, the medical college. This, by the way, is medical college. This is Ayurvedic and Dental College. These are hostels. This is administrative block. These are hostels. This playground. This is the medical college, which was being built, and these are the fields which were greatly affected initially, and these are the fields which got affected little later on. 23rd October 2018, long shot premises being developed. 21st January 2018, 17th January 2019, 8th February 2019, 20th January 2021. Several things are right in place. Landscaping being done, and also lot of wastewater being generated. Now let us get into a close-up view. Here you can see this valley and this. This valley is still more or less dry. This valley has little water. It's February 2011. On 29th October 2013, you can see that the place is under construction and developing, and naturally wet areas are there post monsoon. 29th October is the time immediately after monsoon. So these areas can be considered naturally wet because of the rainfall. 3rd April 2015. There was this STP setup, functional, non-functional, dysfunctional, whatever. And the water, treated water, kept on coming out into this area. Note this appearance of green patch over here. See that this valley is dry. 18th December 2015, the green patch spreading. Upper valley is still dry. 26th January 2016, first appearance of floating wind patch. Upper valley is still dry. 18th March 2016, there is increase in intensity of green patch, floating wind. The medical college by now is under construction. 11th January 2017, there is green patch which is almost drying, but the extent of green patch has increased. Upper valley is still dry. This is very curious kind of development because this is immediately after December vacation. Probably they had some extended vacations, and hence the area was dry in the upper part, but the wetness had spread further. 23rd October 2018, medical college is there. STP is also there. Green patch is growing thick. Wetness has moved ahead, and also notice the upper patch, the upper valley. Upper valley is also green. This is not just presence of rainfall. This is the time where medical college became fully functional and their wastewater was coming out into a septic tank, and after septic tank it was dumped where it is sleeping. 28th January 2021. Note the greenness in the upper valley. Note the wetness movement Note the floating weed mound. This is all natural. These are the places: medical college, hospital, laundry. This is the last pipe location. And then what we did was we did chemical analysis of the waste. We selected these collection points. The medical college last chamber, it was not connected to ST. Laundry common chamber, hospital pathology and blood bank common chamber. All these three came together, not three. The medical college did not connect. Laundry, pathology, the blood bank, and the remaining hospital. They connected to the STP, which is non-functional. And from there, through a large pipe, came down out into that we call as last pipe. It poured into a valley, shallow valley. Then we took a sample 100 feet away from. Then we took in the field with the cattail. Then we took further downstream of the cattail, open. And there was a pit dug for some reason away from those cattails. And we said we'll take sample from here. And the results are fantastic. There's a lot of learning in these numbers and a lot of possibilities of future. As you can see, the color was 10 Hazen units in initial things. Immediately after opening onto the soil and draining about 100 feet on open soil, color reduced. It increased again in the fields of cattails. Downstream, it reduced again. And in the pit away from those cattails, it increased much. The odor everywhere was decided. Right? Turbidity was less in medical college last chamber. Laundry, it was much more. Hospital and pathology, it was not so much. When it mixed with the hospital and canteen and other wastewater toilets, it increased 70. Away from the drain, it reduced. In the field of cattails, it increased. Downstream, it reduced again. And in that pit was still further. pH shows great variability. Similar variation is seen in TDS. You can see the laundry contributes maximum TDS. Other areas don't add so much. Hardness is not so much in laundry. Calcium ions also are not so much in laundry. Obviously, laundry needs soft. They reverse osmosize that water and give it to people for drinking and for laundry. These are other results. Iron, varied, phosphate, very distinct. In other places, there was not so much phosphate. Laundry had so much, 25.1. Other places were below detectable limit, detection limit. For drawing graphs, I have to put those numbers in. Sulfate, again, not so much in laundry. Plenty of it in the sewage water, obviously. But as it goes away from the last pipe, it starts reducing. There is plant uptake, there is fixation, there is conversion to H2S from where it just volatilized. Several parts. Nitrates are more in laundry common chamber. Then they started reducing downstream of cattails. They show these are real results, composite samples. More study certainly is needed, but we can see very clearly how nature is treating this way. You can see the fluoride laundry wastewater at maximum, of course within limit, but maximum. Then it started reducing. MPN number, bacteria. No bacteria in laundry waste. Detergent kills it. Then again, there was some number and it started reducing. In that pit away from cattail sitting, E. coli, absent, 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 present, absent. We'll talk about it. POD 128 in the medical college last year, post-septic. POD 40. Maximum POD came in from laundry. 812. Blood bank and pathology did not give some. The last pipe location gave no, because there is canteen wastewater coming in, there is hospital toilets coming in, office toilets coming in. And then you can see the wastewater is improving its BOD and COD. To what extent? 60 BOD, COD and 8 BOD. 60 COD and 10 BOD. Not a single blower, not a single aerator. No chemicals added. Nothing. No sand filter, no carbon filter, no chlorination, no ozonation, nothing. Nature worked on it just by herself. Absolutely, without any effort from human mind. Nature converted composite sewage of this quality of water into fairly good quality. No one in that organization knew that this is what is happening there. We collected those samples and we showed it to them, and they would say, "Oh, this is what is happening. Wonderful. We never knew of it." I said, "Wait, we will make use of this knowledge and improve on it." And that is what we suggested. But before going to our suggestion, I will take you through graphical presentation of the data that we collect. As you can see, pH is not much off. Here in the right hand side top graph, common graph of color, odor, turbidity, pH. Because of the turbidity value, the other values became small. So we said, let us separate them and study. Turbidity graph left lower, you can see medical college, laundry, pathology, and then last pipe. Last pipe has maximum because of kitchen and toilet. And further you can see it reduce. TDS maximum in laundry, then further reduce. Hardness, calcium, phosphates, sulfates, fluoride, nitrates. Excellent variation, excellent pathways of managing nitrogen. Nitrogen is very essential for plant life. Those are the only ones which can bring nitrogen into the food chain. They make it, they break it, they manage it, they increase it, they decrease it, depending on the need of that ecosystem. MPN, BOD, and COD. Many mechanical treatment plants strive very hard to get these results. They spend huge amounts to get these results. Mother Nature gets those results provided she gets time and space to work. If we are not in hurry, or if we are hurried in planned manner, we can give her time, space. She finds her own energy and does wonders which mechanical treatment plants can hardly even dream. Not a single blower, no diffuser, no mechanism of any, no filters, sand filter, carbon filter, chlorination, ozonation, ultraviolet, nothing, nothing. And yet the system functions absolutely fine. These are the numbers. Once again, generally people feel and think and teach that BOD COD ratio is 1 BOD and 3 COD. You can see here the numbers are way off. 1 BOD and 10 COD. Such are the numbers. They happen because of our disinfectant use. That happens because of our detergent use. Our sewage is no longer the sewage which was 50 years ago. And hence 1:3 does not function. And yet this natural system can take care of it. Last pipe location 55 BOD, 580 COD, more than 1:10. The fields with cattails 8 BOD, 60 COD. It improved the BOD COD ratio. It reduced the values of BOD and COD. Now this is what we had proposed to them. This is their valley into which the wastewater was naturally glowing. These are the improvements which we had suggested. Widening of the path of water, then regulating the path, creating appropriate multi-species native, moral, species plantation, and then a well near the pollution point. The well water would be used for landscaping and growing vegetation in their own area. This is the initial part, cross section, where the valley is steep. Presently, it is just pouring through a pipe onto a rock below and just spilling away. By designing it, we'll give it sufficient width, sufficient depth, and good area for treatment for. We'll collect it into a lagoon and allow that lagoon to pass through its wastewater into horizontal treatment. Series of. From field to field to field to a pond, and from a pond to the well. This is cross section through the stream. This one is along the stream. This one is through the stream. We would make use of it as a kind of aesthetic and biodiversity garden, like bridges, benches. As it is, this is a beautiful place developed by Mother Nature. We will try and make it further good looking. So these natural forces, without any efforts from human mind, converted the composite sewage to the quality that you have seen. And hence, there is need to rethink about our understanding of nature and nature. We need to re-evaluate what we have learned from US EPA. We need to re-evaluate our discharge characteristics, discharge norms. We need to educate our pollution control boards about immense possibilities which Mother Nature offers. If we want to have self-reliance, Atmanirbharta, for that Atmanirbharta, we need to divorce USEP. All our norms, more or less, are copy-pasted from United States Environment Protection Agency. Why do we need it? Our nature, our biodiversity is different from the wood. This place is an unengineered place and it functions. And there are many engineered places which are non-functional. Hence, to NIH is this request of mine to further study this and similar situations and come to such understanding that without wastage of electricity, without wastage of or addition of chemicals, we should be able to treat waste. We have done it in hundreds of places. But this is something that we did not do. Mother Nature. We are absolutely thankful. We are only documenting. That is something that I wanted to share with all of you. If you have any queries, I'll be happy to answer if I